We use the sine rule to find a missing length or a missing angle in a non-right angled triangle. So for right angled triangles, we have Pythagoras and SOHCAHTOA. But for non-right angled triangles, we can use the sine rule or the cosine rule. So here we've got the sine rule. So we've got A over sine A equals B over sine B. So the little a's are lengths. So if this was little a, the big A's are the angles, and little a is opposite big A. So if this is little a, opposite it is big A. If this length is little b, opposite it is big B. So sine rule is for opposites. There are two versions of the formula of the sine rule. We use lengths on top to calculate lengths. So A over sine A equals B over sine B for lengths. And for angles, we just flip it over and put the angles on top. Sine A over A equals sine B over B. We do that to make the working out easier. So let's have a look at an example. This question says find the value of x. The first thing I'm going to look for is opposites. Do I have opposites? So can I use the sine rule? So I've got x opposite 85 and I've got 12 opposite 53. So I can use the sine rule. I'm working out a length, so I'm going to use the sine rule for lengths. So I'm going to put the lengths on top. A over sine A equals B over sine B. So the little a's are the lengths, the big A's are the angles. So if x is little a, 85 is big A. If 12 is little b, 53 is big B. And we just need to substitute these in to our sine rule now. So little a we're going to call x. Sine A, big A is 85. So x over sine 85 is equal to, our little b we're calling 12. And 12's opposite is 53. So 12 over sine 53. The angles always go with the sines. We want to get x by itself. At the moment, x is divided by sine 85. So to get rid of that, we multiply both sides by sine 85. So x is equal to 12 over sine 53 times sine 85. And we can just type this exactly how it looks into the calculator to find x. So I'm going to write fraction button 12 over sine 53, and then all of that times sine 85. And I've got an answer of 14.968 and so on. I will give my answer to 2 decimal places, so that'll be 14.97. So x is 14.97 and it's centimeters to 2 decimal places. Okay, a question for you to try. So pause the video and give it a go. Okay, so firstly, do we have opposites? So x is opposite 34 degrees. 15 is opposite 97 degrees. So we can use the sine rule. We're working out lengths again. So we're using the sine rule for lengths, which is A over sine A equals B over sine B. So if we have x as little a, that means 34 is big A. If we have 15 as little b, that means 97 is big B. So substituting in, little a is x, so x over sine, a's opposite is 34. equals 15 over 15's opposite, which is 97, so it'll be sine 97. To get x by itself, we're going to multiply both sides by sine 34. So x is 15 over sine 97 times sine 34. So we type into the calculator exactly how it looks. And again, I'm going to give the answer to 2 decimal places. So we've got 8.45 this time. And again, centimeters, and I'll write 2dp. Okay, another example. So this time it says find the length of AB. So AB is this length here, A to B. So I'm going to call that X. And I'm looking at my opposites. So 8.5 centimeters is opposite 81. So I've got one opposite there. But X's opposite angle, I don't know. So can I use the sine rule? If I don't know this angle, I can't, but I can work out that angle. So the angles in a triangle add up to 180 degrees. And we've got 81 and 39 here. So we can find the missing angle. 81 and 39, that makes 120. And 180 minus 120 is 60. So you can use a calculator. So we can work out that 60 degrees. And we can use the sine rule because we do have opposites. So we're working out a length again. So we're going to put the lengths on top. A over sine A equals B over sine B. And I'm going to label it again. So I have X as little a, so 60 will be big A, and the other length is little b, and its opposite is big B. So we substitute in. So A over sine A, so X over sine 60. Equals 8.5 over sine 81. So X over sine with its opposite equals 8.5 over sine with its opposite. We want to get X by itself, so we're going to multiply both sides by sine 60. And we just type this into the calculator to get our answer. So 8.5 over sine 81 times sine 60. And 2 decimal places again, I've got 7.45. Still centimeters to 2 decimal places. Okay, a question for you to try. So pause the video, give it a go, and press play when you're ready to carry on. So find the value of BC. So we're working out the length B to C. And do we have opposites? Can we use the sine rule? So we've got 9.3 opposite 52. We don't know X's opposite just yet, but we can work it out from finding the missing angle in a triangle. So 180, take away 52, and take away 93, tells us the missing angle is 35 degrees. So we do know opposites. We've got x and its opposite is 35 degrees. 9.3's opposite is 52 degrees. So we're going to use the sine rule for lengths again. So it's going to be x over sine with its opposite, which is 35, is equal to the other length, 9.3, over sine with its opposite, which is 52 degrees. So multiply both sides by sine 35. So x is 9.3 over sine 52 times sine 35. Type it into the calculator. And to 2 decimal places, I have 6.77. It rounds up, so 6.77 centimeters to 2 decimal places. Okay, this time we're being asked to work out an angle. So the question says find the sides of angle ABC. That means ABC, this one here. So, do we have opposites? Can we use the sine rule? Our angle X is opposite 5.2, and our other angle 96 is opposite 9.1. We've got opposites. We can use the sine rule. This time, we're going to use the sine rule for angles. So it's going to be sine A, sine big A over little a equals sine big B over little b. So the sine always goes with the angle, and it's the big letter is the angle, and the little one is the length. So this time we're going to have x as big A, and opposite it, 5.2, will be small a. Our other angle is going to be big B, and its opposite will be little b. So let's substitute in. So we've got sine x this time over its opposite, which is 5.2, equals sine 96, the other angle on top, angles are on top this time, over its opposite, which is 9.1. So we're going to get sine x by itself by multiplying both sides by 5.2. So we're going to have sine x is equal to sine 96 over 9.1 times 5.2. So we'll type that into the calculator and we'll get our answer for sine x. We'll know what sine x is. So sine 96 over 9.1 times 5.2. So we've got 0.568 and so on. So I'll write sine x is equal to 0.568 and so on. But that's sine x, that isn't x. So how do we find x? How do we get sine away from x? We do the opposite of sine, which is shift sine. So the inverse of sine, shift sine. And then we do our answer in there, shift sine answer. And we get our angle. So 34.63 to 2 decimal places. So x is 34.63 degrees to 2 decimal places. Okay, a question for you to try. So pause the video, give it a go, and press play when you're ready for the answers. Okay, do we have opposites? So we've got our angle x opposite 18 and our angle 57 opposite 25. So we've got opposites, so we can use the sine rule. If we have x as big A, that means 18, its opposite is going to be our little a. And if we have 57 as big B, its opposite, 25, will be little b. So we're going to use the sine rule for angles. So the angle's on top. So sine always goes with the angle. So sine x over its opposite, 18, equals sine 57, the other angle, with its opposite over its opposite, 25. We'll get sine x by itself by multiplying both sides by 18. So sine x equals sine 57 over 25 times 18. So let's type that in the calculator. So we've got 0.603 and so on. But that's sine x. We want x. So to get rid of sine, to get sine away from x, we shift sine. So shift sine the answer. And that's 37.15 to 2 decimal places. 37.15 degrees, and again 2 decimal places I'm giving my answers to. Okay, one more example of this. This time angle CAB is obtuse, and that is important. So obtuse means between 90 degrees and 180 degrees. So the angle is obtuse. Work out the size of angle CAB. CAB. So this is x, CAB. Do we have opposites? We do. So our angle x is opposite 12. Our angle 44 is opposite 8.6. So we're working out angles. We can use the sine rule for angles. So sine A over A equals sine B over B. Working out angles, we put the angles on top. The angles, the big letters, the capital letters, always go with the sine. So we've got sine A, which we're going to have as sine x. I'll quickly label that. So big A, little a, big B, little b. So sine x over its opposite, which is 12, equals sine the other angle, 44, over its opposite, which is 8.6. To get sine x by itself, multiply both sides by 12. So sine x is sine 44 over 8.6 times 12. So let's type that into the calculator. So sine 44 over 8.6 times 12, and we've got our sine x of 0.969 and so on. 0.969 and so on. But we're going to find x. So to get sine away from x, we're going to do shift sine. So if we shift sine the answer, we get an answer of 75.76. So I've got 75.76. I'll write that down, 75.76 degrees. But hold up, that's acute. We want to work out an obtuse angle this time. And we've been given an answer that is less than 90. So the calculator's given us an answer, but it's not the answer we want. So we want an obtuse answer, an answer between 90 and 180, and the calculator's given us 75.76. So to find our correct answer, we're going to do 180 take away the answer we were given and get 104.24. So x is going to be 104.24 degrees, and I will explain how that works quickly. So if we've got a sine graph, which looks something like this, so we've got sine x, and I'll write the y-axis, and the sine graph is a wave. And it's a wave and it goes on forever. And I'll write 90, 180, 270, 360. And we had 0.969. So we said to the calculator, I've got 0.969. Tell me what angle that is. And it said the first angle. The calculator always gives us the first angle on the graph, which is 75.76. And usually that's okay. We're happy with the first one. But in this case, we actually wanted the second one. And the calculator doesn't give us that answer. So we have to do an extra calculation. And using this symmetry, so saying the same gap here, so this gap here, which was 75.76, is the same as this gap here. We can work out the second answer by doing 180, take away 75.76 to find the second answer. So when we are finding an obtuse angle with the sine rule, we do 180, take away the answer the calculator gives us to find the obtuse angle. Okay, let me clear this. And here's a question for you to try. So pause the video, give this one a go, and press play when you're ready for the answer. So this question says find the possible values of x. So there's going to be two possible answers. The diagram's not drawn to scale, so there could be an acute answer and an obtuse answer. And let's just quickly go back and say that that wasn't possible in the previous two questions, because in this first question here, if we'd done 180 minus 34.63, we would have had an angle of 145 degrees, and that wouldn't work because that would go over 180. And again, for this second one, if we had an answer of 143 degrees, that would be over 180, so there's not two possible answers. So back to the question, find the possible values of x. So firstly, can we use the sine rule? Do we have opposites? And the answer is yes. We're working out an angle, so we're going to use the sine rule for angles. So angles on top, sine A over A equals sine B over B. We're going to call our x big A, and opposite will be little a. Our other angle is big B, opposite it is little b. So sine x over its opposite, which is 5.2, equals sine with the other angle, 31, over its opposite, which is 2.7. So sine x multiplying both sides by 5.2 is sine 31 over 2.7 times 5.2. So we're going to type it into the calculator. Sine 31 over 2.7 times 5.2. So we've got 0.991 and so on. That's sine x. To get x by itself, I'm going to shift sign. So shift sign my answer, and that's 82.71 to 2 decimal places degrees. That's one possible answer. That's the acute answer, but there's also an obtuse answer. So 180 take away the answer, and that's 97.29. So it could also be 97.29 degrees. Okay, to finish up, 2 questions. Pause the video, give them a go, and press play when you're ready for the answers. Question 1, find the length of BC. So this is going to be x, b to c. Do we have opposites? X is opposite 96. 9.1 is opposite 57. We're working out a length. So let's use the sine rule for lengths with the lengths on top. So a over sine A equals b over sine B. So we can have x as little a, opposite it will be big A. The other length, little b, opposite it will be big B. So we've got x over sine with 96 equals the other length, 9.1, over sine with its opposite, which is 57. And to get x by itself, we're going to multiply both sides by sine 96. And then we're going to type it into the calculator. So we've got 9.1 over sine 57 times sine 96. Type it into the calculator and we get 10.79 to 2 decimal places. So x is 10.79 centimeters to 2 decimal places. Question 2, find the value of x. This time we're working out an angle. Do we have opposites? Yes, we do. So we're going to work out an angle. So let's put the angles on top. So we have big A and little a, big B and little b. So sine always with the angles. So sine A, sine x over 3.5 equals sine with the other angle, 99, over 4.4. We want sine x by itself, so let's multiply both sides by 3.5. So we can type that into the calculator to get our sine x. So sine 99 over 4.4 equal, no, sine 99 over 4.4 times 3.5 is 0.785 and so on. And we want to get x, so to get sine away from x, to get x away from sine, we shift sine. So we're going to shift sine our answer, and we get 51.78 to 2 decimal places. So 51.78 meters to 2 decimal places.